Oh shoot, I hit the wrong button. So this is our fourth video. I meant to hit the other button, which would have just started recording me again. But anyway, here's the example that we just did, that you just did hopefully. And hopefully you got 18 as the average rate of change of this same function, but from 1 to 5 instead of from 1 to 3. Okay? And then finally our last page, this should take just a moment. The secant line, that line that I drew through the graph, we call it a secant line. Okay? And that secant line has a slope. And that's what this is here. M with that SEC. M with the SEC represents the slope of the secant line. And that should be an equal sign there. And the slope of the secant line, we have C right here, C comma f of C. And then we have some random value x comma f of x. Well, those 2 points are points on the curve y equals f of x. So, you know, if this is an a over here, then right over here this is a comma f of a. So hopefully the notation here isn't confusing you. But if you want to know what the average rate of change is from this value here c to this value here x, you would use that formula, f of x minus f of c over x minus c. Well, that just so happens when we put the x's and the c in there, usually referring to the slope of the secant line. And that's exactly what that is. So the bottom line is, to come in for a landing, the average rate of change of a function from a to b equals the slope of the secant line containing the 2 points a comma f of a and b comma f of b on its graph, as we just saw. So hopefully you have been able to follow along. Hopefully you didn't wait until midnight or 1 a.m. to watch these videos, and I will see you in class.